In this episode, we're going to make metrics feel like a practical leadership tool rather than a confusing scoreboard, because metrics are one of the main ways an AI security program stays real over time. When beginners hear metrics, they sometimes imagine a pile of technical numbers that only engineers care about. But in governance, metrics exist to support decisions. Leaders need to know whether risk is being reduced, whether obligations are being met, and where resources should be allocated next, and they can only do that reliably when the program produces clear signals. AI security metrics are especially important because the risk landscape can shift quickly and because harm can occur through outcomes, not just through classic security breaches. If leaders cannot understand what is happening, they will either ignore the program or make decisions based on fear and headlines rather than evidence. The AI Security Manager, AAISM, perspective is to choose metrics that align to objectives, are easy to interpret, and trigger concrete action when they move. By the end, you should understand what makes a metric useful, what categories of metrics leaders tend to need, and how to avoid metrics that look impressive but do not improve safety. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A strong metric begins with a clear connection to a decision, because a number that does not change a decision is often just noise. A useful metric answers a question like, where are we exposed? Are we improving? And what should we prioritize next? It also reflects an aspect of risk or control that the organization can influence, because metrics should motivate action rather than resignation. Beginners sometimes assume the goal is to measure everything, but measuring everything creates confusion and distracts from what matters. Instead, the goal is to measure a small set of signals that summarize the health of the program and the direction of risk. Leaders also need metrics that are stable enough to compare over time, but sensitive enough to detect meaningful change. In AI programs, metrics must account for both governance controls, like assessments and approvals, and operational controls, like monitoring and incident response, because both shape real risk. Another important point is that leaders need context, meaning a metric should be paired with a clear interpretation, like whether a rising number indicates improvement or worsening risk. When metrics are tied to decisions and interpretation, they become a management tool rather than a reporting ritual. It helps to distinguish between activity metrics and outcome metrics, because beginners often confuse effort with effectiveness. Activity metrics measure what you did, such as how many training sessions were delivered or how many documents were created. Outcome metrics measure what changed, such as reductions in risky behavior, improvements in coverage, or faster detection and response to incidents. Activity metrics are not useless, but they are weaker on their own because they do not prove risk is being reduced. A leader can authorize 1,000 hours of training, but if people still paste sensitive information into unapproved tools, risk remains. Outcome metrics are often harder to measure, but they are more valuable because they reflect real-world impact. A mature program uses a balanced set of metrics, where activity metrics support an understanding of effort and capacity, while outcome metrics show whether the effort is working. In AI security, outcomes can include fewer unsafe outputs, fewer unapproved tool uses, higher completion of impact assessments for high-risk systems, and fewer unresolved high-risk findings. Beginners should understand that the best metrics are those that encourage the program to improve rather than to look busy. When you design metrics with this distinction in mind, you avoid the trap of measuring motion instead of progress. A practical first category of metrics for leaders is visibility and coverage, because leaders cannot manage what they cannot see. These metrics describe whether the organization knows what AI systems exist, who owns them, and what data and dependencies they touch. A useful metric might indicate the percentage of AI systems inventoried with complete ownership and classification information. Another useful metric might track how many systems are missing key inventory fields, such as data sources or vendor dependencies. Beginners should see these metrics as foundational because they tell leaders whether the program has basic control. Without coverage, other metrics become unreliable because they may only describe the system's governance already knows about. Visibility metrics also help leaders prioritize inventory cleanup work because missing inventory data is itself a risk signal. A strong program can also track the rate of new systems entering inventory through formal intake versus being discovered later, because discovery-based growth suggests shadow adoption. Leaders can act on these metrics by investing in intake processes, improving communication, or adjusting approvals to reduce bypass. When visibility metrics improve, the program gains a stronger foundation for consistent oversight. A second category is risk tiering and assessment completion, because leaders need to know whether high-risk systems are being treated with appropriate rigor. A useful metric might show how many systems are classified as high-impact or high-compliance scope, and how many of those have completed impact assessments within required timeframes. Another metric might show the backlog of required assessments, broken down by risk tier, because backlog indicates where risk may be unmanaged. Beginners should notice that this category connects directly to defensibility, because an organization that cannot show assessment coverage for high-risk systems looks careless. Assessment metrics also help leaders allocate resources, such as adding reviewers, improving templates, or streamlining processes to reduce delays. Another valuable metric is the average time from intake to assessment completion for high-risk systems, because excessive time can encourage bypass and reduce business trust in governance. Leaders can act by improving governance efficiency while preserving rigor, which is the balance mature programs aim for. When assessment metrics are clear and timely, leaders can see whether the program is staying ahead of risk or falling behind. A third category is control implementation and control effectiveness, which tells leaders whether requirements are becoming real protections rather than remaining as policy language. Control implementation metrics might track whether key safeguards are in place for systems by tier, such as access control reviews completed, monitoring plans established, and change control defined. Control effectiveness metrics go further by tracking whether controls actually reduce risk, such as reductions in data exposure events or reductions in unauthorized access attempts. Beginners should understand that measuring effectiveness can be challenging, but you can still use proxy signals, such as the number of detected unsafe outputs and the speed of response and remediation. Another useful metric is the number of open high-severity findings from assessments and reviews, because open findings indicate residual risk not yet addressed. Leaders can act on these metrics by prioritizing remediation work and by addressing systemic gaps rather than isolated fixes. Control metrics should be designed to avoid rewarding superficial compliance, such as checking a box without verifying functionality. When control metrics reflect both presence and performance, they support real safety improvements. A fourth category is data risk and information handling, because AI programs often succeed or fail based on how well they control sensitive data across prompts, outputs, training datasets, and logs. A useful metric might track the number of detected instances of sensitive data appearing in prompts or outputs within monitored systems, especially for systems classified as high sensitivity. Another metric might track compliance with retention schedules, such as the percentage of systems with prompt and output logs configured to meet retention requirements. Beginners should understand that these metrics must be used carefully because detection capabilities and definitions affect what you count, and leaders need consistent interpretation. Data handling metrics can also track access review completion for sensitive datasets and the number of exceptions granted for data use, because frequent exceptions can indicate process gaps or inadequate approved tooling. Leaders can act by strengthening training, refining acceptable use guidance, improving access boundaries, or approving safer tools that reduce the need for risky workarounds. Another valuable metric is the volume of sensitive data stored in AI-related repositories over time, because rising volume can signal retention failure or uncontrolled copying. When data metrics are tied to clear actions, leaders can reduce long-term exposure and improve compliance posture. A fifth category is change management and stability, because AI systems change frequently and changes can introduce new risk. A useful metric might track the number of significant changes to high-risk AI systems that were processed through formal change control versus changes discovered after the fact. Another metric might track the frequency of unplanned behavior changes, such as output drift events or performance regressions that trigger investigation. Beginners should understand that high change frequency is not automatically bad, but uncontrolled change is a risk, and metrics should differentiate between controlled updates and unmanaged surprises. Change metrics can also include the percentage of systems with documented change triggers that require reassessment, because reassessment discipline is part of safe evolution. Leaders can act on change metrics by improving change control processes, adding validation steps after updates, and strengthening vendor oversight when changes are vendor-driven. Another important metric is time to validate after a major update, because slow validation increases the window where unsafe behavior could affect users. When change metrics are clear, leaders can manage AI evolution responsibly without freezing innovation. A sixth category is incident and response readiness, because leaders need to know whether the organization can detect and handle AI-related harm quickly. Useful metrics include how many AI-related incidents or near misses were reported, how quickly they were detected, and how quickly they were contained and resolved. Beginners should recognize that an increase in reported near misses can be a positive signal if it reflects improved reporting culture and detection rather than worsening underlying risk. This is why interpretation matters, because the same number can mean different things depending on context. Another useful metric is the percentage of AI systems that have defined escalation paths and monitoring routines, because readiness depends on having plans in place before incidents occur. Leaders can act by investing in monitoring, improving reporting pathways, and ensuring system owners are trained to respond. Incident metrics should also track lessons learned implementation, such as whether post-incident actions were completed on schedule, because repeated incidents often occur when fixes are not implemented. When response metrics improve, the organization becomes more resilient and more defensible under scrutiny. A seventh category is training and behavior, because many AI risks are driven by human habits rather than by technical failure. Useful metrics include training completion rates, but more importantly, signals of behavior change, such as reductions in use of unapproved tools, reductions in policy violations, and increases in early reporting of unsafe outputs. Beginners should understand that behavior metrics can be measured through surveys, reporting patterns, and monitoring signals, but they must be used with care to avoid creating fear that discourages reporting. Another useful metric is the number of questions and escalation requests related to acceptable use, because high volume can indicate confusion or rising interest, and both require action. Leaders can act by refining training, clarifying guidelines, and improving approved tool availability so employees have safe options. Training metrics should also include refresh cadence, meaning whether training is updated when threats, tools, and regulations change, because stale training creates silent risk. When behavior metrics improve, the organization reduces the most common sources of leakage and misuse. Leaders can then trust that the program is influencing daily work rather than existing only on paper. To make metrics leader-friendly, the program must present them in a way that supports action, which means clarity, consistency, and context. Each metric should have a clear definition, a clear time window, and a clear target or threshold that indicates when attention is needed. Beginners should understand that without definitions, metrics become arguments because different people interpret them differently. Metrics should also be normalized where possible, such as using percentages or rates rather than raw counts when the number of systems changes, because raw counts can be misleading as the program scales. Another important practice is showing trends over time, because a single snapshot can be misinterpreted, while a trend shows whether the program is improving or deteriorating. Leaders also need brief narrative interpretation, like what the metric means and what actions are recommended when it moves in a certain direction. Metrics should also avoid creating perverse incentives, such as discouraging reporting or encouraging teams to classify systems as low risk to avoid oversight. A mature program designs metrics so they promote safe behavior and honest visibility. As we wrap up, defining AI security metrics that leaders can understand and act on is about choosing a small set of signals that connect directly to decisions, risk reduction, and defensible oversight. Useful metrics balance activity and outcomes, and they focus on foundational areas like inventory coverage, risk tiering and assessment completion, control implementation and effectiveness, data handling exposure, change control discipline, incident readiness and response, and training-driven behavior change. Each metric must be clearly defined, consistently measured, and presented with context so leaders can interpret it correctly and take concrete action. The goal is not to impress with complexity, but to create a dashboard of reality that helps leadership allocate resources, enforce accountability, and improve governance routines over time. For new learners, the key takeaway is that metrics are how a program stays alive, because what gets measured gets managed, and what leaders can understand is what leaders can fix. When metrics are designed thoughtfully, they become one of the strongest tools for making AI security sustainable, scalable, and defensible.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.